So we're reviewing our pamphlet. Quickly, we'll go to a section that is compulsory in our exams, short word answer questions. So we're going to look at section B, the short word answer. So we're going to answer these questions. But before we answer these questions, maybe peradventure, I could go through a few notes that we looked at briefly. So in terms of variables in research, we talked about uh, variables being independent and dependent variables. Okay, so what are dependent variables? The variables that we are manipulating. And independent variables, the variables that we are doing what? Uh, we are studying the outcome. We also went into talking about moderating variables. Okay, so I hope you remember the moderating variables. Then we later on went to talk about measures of distribution in research. So when you're dealing with measures of distribution in research, we looked at issues to do with what? Standard deviation. When our standard deviation is high, it means that we are deviating as much from our expected outcome. So standard deviation is a measure of distribution which helps us explain the spread of the numbers around the mean, like we do in QM. So the idea is about studying the consistency of the data. So when your standard deviation is small, it means that our data points are close to the mean. When the standard deviation is large, it means that our data spread is what? Spreading outwards. Okay. So if you have a small standard deviation, it means that what? We have more accurate data. We also talked about inferential analysis or statistics. What did we say? We said inferential analysis involves you using a sample to draw conclusions over a big population. That is what we call inferential analysis. So it includes you having tests like the t-tests, the chi-square, the z-test, the confidence intervals. So if you have a survey of, say, 500 students, okay, uh, talking about their favorite sport, and you see that 60% will prefer football. According to financial statistics, we can say that the majority love football. That's what um, we had discussed. So we also went to discussing issues of what? Validity in research. What did we say about validity? When measuring validity, there are several types of validity. There's what we call content validity, which looks at whether the test will cover the full content. We have construct validity, which actually asks us whether the measure is the instrument is measuring the concept that it's supposed to measure. We also have criterion validity, which answers the question whether it predicts the related outcome. Does it predict the related outcomes? So validity is more about what? Measuring accuracy, whether the tool is accurately measuring what it claims to measure. It is different from reliability. Reliability is about consistency. Okay, so there are four types of validity. There's content, construct, criterion, and which one? The types of validity. Surely.
Um, Sorry, I think I missed the ones you had mentioned. So
Okay.
content,
Uh-huh.
criterion,
Mm-hmm.
okay, I think I've
Anyone to
forgotten the
help?
other one.
The four types of validity and four types of reliability. Who remembers?
They should be construct, am I correct?
Uh-huh. Is she right?
Yes.
Tell me the four types of validity and four types of reliability. Okay. We're running out of time. Face validity.
Yes, validity, yes.
The content is about
Mm.
how well the test measures the range of the concepts. The construct is whether the test actually measures the theoretical concept it wants to measure. Criterion, it looks at how well one can measure or predict the outcome based on the other measures. So under criterion, there are two types. There's predictive and concurrent, remember. Then we have face validity, which measures whether the test appears on face value to measure what's supposed to measure. Then reliability, we talked about the four types of reliability. Who remembers them?
Test, retest,
Mm-hmm.
in,
Yes. Retest.
inter,
Interesting.
Mm-hmm.
iterator,
Mm-hmm.
and
Internal consistency, reliability, and parallel forms. The test retest looks at over time whether the results will be the same. Iterator looks at consistency between different people, the observers. Internal consistency looks at within the same item, whether the test measures the same idea, and we use a Cronbach alpha. In parallel form, we are using different versions to measure the same test. Remember? So these are the ones we talked about under reliability. This doesn't miss out. So I'll be repeating this almost every class we have. Then we also looked at the research designs. Okay, we talked about research designs that fall under qualitative and research designs that fall under quantitative. Okay, so there's a correlational research which is used to measure the natural relationships that exist. Okay, correlation research design, which we use to measure what? Natural relationships between variables without manipulating them. So this correlation is only used to identify associations, but not cause and effect. It doesn't measure causality. So, for instance, a researcher wants to study the relationship between study hours and exam performance, but doesn't want to control how each of them. So you can use what? A correlation. Okay. So we talked about the types of what types of research designs are under quantitative and what types of research designs are under qualitative. Eh? What types? Because you need to know the types of research designs under each category. Okay? There are many, but we discuss that you're able to understand. So which research designs are under qualitative and which research designs are under quantitative? So we said under quantitative, we have many, but the most common are the descriptive, which describes the characteristics of the population. Correlation, it examines the relationship between two or more variables. Experimental, it is used for cause and effect. Quasi experimental, it has a combination of two, okay? It is similar to experimental, but without random assignment. Then we look at the types of qualitative research designs. Is phenomenological, which explores individuals' lives lived in a phenomenon. Ground theory, which is developed based on a theory or on data collection. Ethnographic, it studies cultures and groups in their natural settings. And we also looked at a case study, which provides an in-depth analysis for a single case. So these are the research designs that pertain to particular researchers. Okay. Then further on, we went to look at issues to do with sampling. Okay, what did we say regarding sampling? Sampling, what is sampling? So under sampling, we talked about the concept of sampling bias, which occurs when some members of the intended population are less likely to be included. Okay, this results into what we call an unrepresentative sample. So for instance, if you're surveying in urban residents, okay, you can generalize about the entire country. It may lead to sampling bias. You can say, okay, Zambians uh, can't afford midi meal because we just went to the rural setting. Or midi meal, or Zambians have rejected the what? This cyber law because you've just looked at those that are opposing or in opposition. So we undergo what is called a sampling bias. All right, a sampling bias. So now I'm trying to cover as much as I can for even the beginners so that um, we can get one or two things as we go the composite questions. So are we together? Are we following?
Yes, we're following.
Okay. So what is sample error? We talked about what is a sampling frame, what is a sampling unit. Who remembers? Um, what are the types of sampling that we have, and how do we calculate sample size? So these we talked about. I'll just be quick and brief to say sampling is simply the process of what? Selecting a small sample from a larger population. The larger population we call it a census. A small population is called a sample. So a sample is simply a subset. And a sampling unit, what is a sampling unit? A sampling unit is simply a basic what? It's a basic unit that we take. It's a basic unit element from a group of elements doing something. For instance, it could be a person, a household, a company, a hospital. So if you're studying students in a school, each student in that school is a sampling unit. All right. So a sampling unit is simply an element of the group. If we're dealing with the um, household, okay, a family member, a sibling, is what we call a um, a sampling unit. We talked about sampling error. Who remembers what is a sampling error? Sampling error is the difference between the actual results from the sample and the actual result we could have gotten from the full population. For instance, you in a field assuming that you're going to have 20 tons, then when you actually get the field, you got 24 tons. The difference between 24 and 20 is called your sampling error. So sampling error is reduced by increasing the sample size. So the more you increase the sample size, the more accurate you are. Okay. So that's a point we talked about. What else did we discuss? Talked about the sampling methods. We have two categories of sampling methods. Who remembers? Probability and non-probability sampling methods. And probability has to do with numbers. Examples of probability method, we have simple random sampling, where every unit has an equal chance. We have systematic sampling, which arises from um, you picking the nth term. All right. Are we together? We also have stratified and cluster sampling. Who remembers um, what stratified sampling is? Stratified sampling, you need to subdivide the entire group into strata. So if you have top management, middle management, lower management, those are called strata. So you're going to pick in each of those categories, maybe three, and each sort you have a representation in the entire group. So we also have what we call cluster sampling, where you're getting the entire clusters of populations. For instance, you have Southern Province, Northern Province, and Eastern Province. So all the 10 provinces are chosen. You just want to choose four provinces. So you just put a random, then you pick all the maybe departmental heads for a ministry. That's called cluster sampling. All right. Then we also have the non-probability sampling. This one, not everyone has an equal chance of being selected. So of these ones, we have the different types. We have what we call convenience sampling, where you can select whomsoever you want to reach the quickest. Are we following? Are we together?
Yes,
We have judgment or purposive sampling. It's type of
yes.
sampling that we have when we are choosing respondents based on what? A certain information that we need to collect from them. For instance, you want to only collect people who have experience in COVID. So um, you will use purposive sampling. Snowball or snowballing comes about when you want to recruit a bigger sample size, all right? So you decide to choose people who knows who, so that the sample size keeps growing. So snowballing is where information is what? Rusty. For instance, you who knows one who does Chitimba, the another Chitimba group, information is kind of scant. Quota sampling, where researchers claims to uh, uh, the researcher ensures certain characteristics are represented. For instance, you're going to have age groups from 5 to 10, 10 to 15, 15 to 20, okay? That is quota sampling. All right, so we also talked about how to calculate your sample size. Sample size selection is very important in research. We have the Slovens and the Yemen's formula. These are very important when it comes to you selecting sample size. So I repeat, when your sample size is small, you rather go for a whole census. There's no need of calculating it. So, but if sample size is more than 100, more than 1,000 at master's level, you use what we call Yemen's formula of 1967, where you have n is equal to n over 1 plus n e to the power to where n is the population size and e is a level of precision or margin of error. So if your population, for instance, is 1,000, you can calculate it. Usually we have 387, usually is the standard whenever I calculate for big samples. It comes out to be something like that. All right. So we go to what other issues did we talk about? We talked about issues to do with the Z test. The t-test, remember from your quantitative methods, we talked about the z-test. So z-test is one of the tests that is used when we are calculating samples that are larger than what? 30. So it is used to compare sample means to population. So for instance, a battery claims to have 500 hours, a sample of 50 shows that the mean lifespan is 480. You can use the z-test to test whether there's a significant difference between the two timings, right? So basically, let's do a quick can you remember. Let's go to our exam now. Please remember everything I taught. Question number 1. In an experiment research, the dash variable is manipulated to determine the effects on the dash variable. So which variable is manipulated?
Independent.
The independent variable. Good. To see the outcome on the what? So the independent variable
Dependent.
manipulated to see the effects on the dependent variable. Correct. Dash measures the distribution of data about the mean value. What measures the distribution?
Standard
Standard
deviation.
deviation.
Good. Standard deviation, SD. What did we say about SD? If the standard deviation is small, what does it mean? The distribution about the mean is minimal. So it means that you are what? If the standard deviation is big, meaning information is scattered. All right. Okay, let's go to question number C. Dash analysis involves getting insight of population by obtaining information from the sample. What analysis?
Could it be inferential?
Yes, inferential. I talked about differential. Okay. Dash refers to how accurately a research tool measures what it intended to measure.
Validity.
Validity, correct. Mm, Dash is a type of research design which measures cause and effect relationship among variables without manipulating any other variable.
Quasi experiment.
Do you agree? The quasi experimental?
or just experimental?
Are you guessing or we are together?
We are together.
What research design? What research design? Dash research design. Dash is a research design which measures cause-effect relationship without manipulating the variables. Correlation. Yes. Who said correlation? Chama. Dash occurs when a sample used in a research study is not representative of the target population. Dash occurs when the sample used in the research study is not representative of the target population.
What have we said on the type of research design which measures the cause and effect? Correlation.
Correlational, yes. Okay, dash occurs when the sample used in the research study is not representative of the target population.
Bias.
Huh? What?
Bias.
Yes, sampling bias, correct. All right. Then we go to G. Dash is a type of inferential statistic used to determine if there is a significant difference between the two groups of the sample, more than 30. You're welcome. Mm-hmm. All right. So, what test is used for samples more than 30?
Z test.
Yes, Z test, correct. Z test. Dash is a sampling method where the researcher chooses respondents at equal intervals from the population. Dash is a sampling method where the researcher will choose respondents at equal intervals.
Systematic.
Systematic, correct. And finally, Dash measures the extent of correspondence between two variables.
Correlation.
Yes, correlation, correct. See, people were very attentive. So thank you so much for your time. It's been a very interactive class. So those who got the pamphlet, please go through the pamphlet throughout it.